Alright, well today we're back to work on the C6 competition drift car build. We are in time crunch mode. We've got a lot of little loose ends, a little odds and ends to finish up. We don't have a ton of time to do it, but I do think we have enough time to get this thing done for round 3 if we just stay focused and finish up all these little odds and ends. So where I want to start today is I want to power this thing up. I want to power up the PDM, power up the ECU, power up the dash, get all of that working. That's the kind of stuff you can fiddle with forever if you have issues. I'd like to get that figured out now and get that sorted because all of the wiring's done. We got our rear harness sitting right there. We've got our front harness in and laid out. So now what we really need to do again is to power up the PDM, program it, which will then allow us to power up the ECU, the dash, and any and everything else. So to do that, we need power. For power, we need batteries. So we have batteries. We have our location of where we're going to put them. We're going to put them in this pocket down in here. Now we just need to mount them. That's one of the last big things to do because we're going to have to make some sort of bracket system to hold these batteries in place. So I want to get that done, get our battery cables around, and then we can try to power everything up, see if it all works. So yeah, enough jibber jabber. Let's get to it. Alright guys, before we get too deep into today's video, I wanted to talk to you about today's video sponsor, Omaze. So I'm really excited to be working with Omaze to bring you the chance to win a Velocity Ford Bronco, as well as supporting a great cause, the Boys and Girls Club of America. Go to omaze.com/Taylor Ray with 2 R's to enter for your chance to win. If I won this thing, man, it would be my summer daily driver, cruise it to the Springs, the beach, pretty much anywhere. And what I love so much about it is the fact that it's the classic Bronco, which is one of the cleanest vehicles ever produced in my opinion. Square and boxy, but smooth and rounded. They are just such a nice looking vehicle. But, you know, you don't want to get in something you don't trust and then you're having issues and you got to tinker with it. But that's where they solved that problem by making this thing essentially a modern vehicle underneath. It's got a Ford 5.0, a Velocity exhaust system, Bluetooth, AC, like everything you'd want in a comfortable, modern, daily driver vehicle, but in this classic, beautiful Ford body. I mean, it doesn't get much better than that. I mean, it is pretty A1 if you ask me. And not to mention supporting the Boys and Girls Club of America, which assures that success is within reach to every young person that walks through their doors. So if you like this Bronco as much as I do and you want to enter for your chance to win, go to amaze.com/Taylor Ray with 2 R's. So huge thank you to Amaze for sponsoring this video. And with that, we need to get back to work. So let's get to it. All right, so for batteries, we have excess power D925 and a super cap the same size. Now, I started using excess power batteries in the Safiro, and I was blown away by how powerful these batteries are for being so small. I had what wasn't even a starting battery in the Safiro, which is now in the Pulsar, and it is no joke the best battery I've ever had. Pulsar used to kill a battery in a few days. Now the battery lasts as long as I want to let the car sit. So we've got our battery here and then our capacitor. So our capacitor is going to take the quick high draw hits, stuff like the electric power steering on tip end, things like that. And this battery is going to handle basically our long-term power, starting current, things like that. So we'll use the super cap for mock-up because it's a lot lighter and kind of figure out where we're going to put both of these and then how we're going to make some brackets to hold them down and mount them. So let's crawl under this thing. It's been a while since we had to do one under the car. I'm half tempted to put the car in the shop, but then we'd have to move everything over, which we don't have time for right now because we gotta get the floors done and we're just gonna lay on our backs. Let's get to it. All right, so I want to avoid mounting them like this because we have things behind this. So I'd like to mount them here on the frame rails. That might work. Main battery there. All right, it's looking like I'm gonna have to put one here and one in the same pocket on the other side. I mean, that'll keep them low center, and we'll put the actual battery over on this side. And then if we do need to switch this one out to a regular battery, we can easily put that over there and then maybe mount this here or something. That's my game plan, at least. This is the best big flat area we've got to work with under here. So let's see what we can come up with a fair amount. This needs to be our sequence of bend to bend back. And it needs to be 2 1/8 wide-ish. 2 to 2 1/8, 2 to 2 1/8. So we need to figure out that total. I don't think I have any more aluminum flat bar. So 1.75 plus 20 by 2. I think we're gonna have to try to make this out of steel. Now the difficult thing is gonna be if we can get all the bends and bends back in a short enough location. So like this one will be fine. The biggest one I'm worried about is when we bend here to go up and then flatten this bend out, not making that distance too tall to where it doesn't hug the top of the battery. But the reason I wanna suck it down in here is that way the battery can't slide left and right. If we just do a single strap over, there's nothing to locate it. I guess unless we did another strap the other way, which might not be the worst idea. All 4 corners bolted. I don't know. Let's see what material we got, see what we can come up with, what we decided to do here. So after some debating, I decided to make this with 2 sides and kind of abandon the multiple bend idea. Now, the reason for that is with the bender that I have, even with this V-die that I built, you have to have a certain amount of distance between each bend. And that minimum distance is about 1 inch. So there's no real way I was going to be able to get those bends to perfectly follow that gap and hold the battery in place securely. I really needed 2 sides to it. Now, I wanted to avoid this because normally I would have built these out of aluminum, some aluminum flat bar. It would have been plenty strong enough to hold up, but also super, super lightweight. But I didn't have any aluminum flat bar. I meant to get some on my last metal store trip, but I didn't. So we had steel flat bar, that's all we had. So making it with 2 sides is definitely gonna make it a little heavy, but it should be very sturdy, and robustness wins over lightweight, I guess, if that's what you got and what you're working with. So the trickiest part here was trying to make these dimensions perfect, because if the height was a little bit off, if the length was a little bit off, it's not gonna hug the battery tight, and it's not gonna hold it in there well like we want it to. So it was really important that we got especially the height dimension right, so that way it kind of squishes the battery down when we bolt it down. That was really the biggest thing I was focusing on. Now this last one fought me a little bit to get the final bend, but we got all 4 pieces done. We made the one a little bit longer so that the other one could tuck under it. We are gonna line these with rubber, so we took that into account, gave ourselves about an 1/8 inch gap or so to put the rubber, and that way once the rubber's in there, it'll isolate it from the battery and keep the metal from rubbing up and wearing against the housing of the battery, and also snug it down just right. Now that's definitely the most difficult thing about building something like this is, you know, if you're an 1/8 inch too tall, it's not going to do its job. It's just going to flop around in there. The battery, nothing's going to be squishing the battery down. So we definitely took our time on that. Measure twice, cut once kind of deal. In this scenario, measure twice, bend once. Got them all welded up, and then went ahead and started drilling out our feet. So we're going to use M8 rib nuts and bolts on this. I think we could have got away with M6, but the battery itself is 25, 28 pounds. So that's a lot of weight to put on some M6 threads and some M6 rib nuts. So I wanted to make sure that it was going to be sturdy. We went with M8, big, hefty hardware. Should be plenty strong enough to hold these in place no matter what. So we got the rib nuts in. That was a bit of a chore drilling upside down, but we got them in. We got the battery bolted up in there. It was also a little bit of a chore. Definitely not the most serviceable location. You know, kind of difficult to get it in and out, but hey, it's part of it. That's what we're working with. That's where we wanted to put it for the best weight balance and really the best open location we had left. There's a lot of things we're trying to cram in this car. So once the battery was placed, we already had our battery pass-throughs place, so we knew where those were. So now it was time to make our battery cables. Now luckily, with the way we designed all this, the battery is really close to the bulkheads, and then the bulkheads are really close to the PDM and the ground kill switch disconnect. So we've got really short battery cables to make. So we get them crimped up with this hydraulic crimper. We get our heat shrink on, get that all shrunk up just to add a little bit of fit and finish to it, and we're done with that. All right, battery is installed and hooked up to the bulkheads, so it's still essentially disconnected. The bulkheads aren't connected to anything on the other side, but we got the cables. I should have made this ground cable a little shorter. It kind of bends close to that positive post, so we'll have to address that. But got them all on there, tightened down. I'm also going to obviously have to paint this, and we'll need to put some rubber on the inside of both of these straps just to, one, tighten everything up. I kind of designed it with a little bit of a gap so we could do that, and then two, obviously to keep it from rubbing on the battery long term. So now we need to make our inside cables. So we'll have a few things going to this post, but the main one will be from here to the PDM. That's going to carry most of the power to all of the different components in the chassis harness, and then our ground will go from here to here, and then we'll have to wire this up so we can kill power to the battery by isolating it from here. So yeah, let's make a couple more battery cables. It's like the shortest freaking battery cable I've ever made, by far. It's literally just the right size. The hard part's gonna be getting the nuts on with these boots. Look at that. Talk about a short little battery cable. Perfect. Alright, before any of our battery stuff will work, we have to wire in our kill switch here. So we're going to cut this here. Oh, also, check it out. We've got something cool that I wanted to do for a long time. We have garage-built magnetic koozies. Better test would be putting it here. Or here. Or here. Or put it up here. Or here. Almost here. But you really need both magnets for a full one. Full soda. But these things are sick. I've had a magnetic koozie for a long time, and it has been life-changing. And I figured we'd make our own. So we've got these on the site, garagebeltcode.com, if you're interested in one. Check them out. Pretty pumped on these. So glad to finally have our own magnetic koozies. Once you have one of these, you'll never go back, and you'll never lose it, because it's always somewhere stuck to something, right? But yeah, works great for doing this kind of stuff. Just a little shameless plug. Alright, we got our PDM grounds done. I drilled and tapped this base plate nice and thick. I don't like to use rib nuts for grounds because the rib nut is zinc plated. So if you were to ground through it, if you were to use it as a grounding bolt area, you're relying on that ground to go through that zinc coating on the body and into like basically a thin strip of metal. It's just not a great way to do it because it has a lip. So drilled this, tapped it, cleaned off to bare metal, got our grounds there. We got this all done. So we've got power that comes out of here, goes to it to power it. Then we've got our switch, and then we've got our off to our PDM. So let's try it. Let's put the button here. Boom. And our this lights up. Ready? Boom. Look at that. Okay, so now I need to get my laptop. I need to get hooked into this. I need to program all of our outputs before we mess around too much. So we've got nothing plugged in right now. I mean, the wiring's there to the connectors, but none of the stuff is plugged in. That way we can make sure we set our parameters, because there might be some default settings that automatically turn on the fuel pumps or something, and then our fuel pumps would start running, you know, as soon as we gave it power. So we're gonna go program all of that before we hook anything up. Then we can start hooking things up one at a time. So let's get hooked up to this and start playing with this software. I'm excited. So we have power. We have power. It's a big moment. As I was messing around with our setup here of the PDM, it kind of dawned on me that I know wiring can be a little mystic. You know, I know when I was growing up getting into cars and when I was younger, and even to this day I hear people say, I hate wiring. I hear that a lot. I hate wiring. Wiring's the worst. I hate wiring. And I think a lot of that stems from just not understanding it. At least that's what it was for me. It's not that I didn't like wiring. There's nothing bad about wiring. It's actually pretty easy in the grand scheme of projects you can do on a car. It's just, it can be confusing. And if you don't understand it like I didn't, you don't like it. So I figured, you know what, to understand how the PDM works and what we're even doing on this laptop here, you kind of have to understand how some simple circuits work. And really, a whole car like this is a bunch of simple circuits. It's really not that complicated at all. And if you understand how the couple different types of circuits work, you can pretty much wire a whole car. It's really pretty straightforward. So let's draw up some diagrams, just quick and dirty little explanation here, and see if we can't demystify this somewhat. Show you how all this different stuff works, which will help you understand how the PDM works and why PDMs are so cool. So enough jibber jabber, let's get to more jibber jabber. Let me draw these up real quick and then I'll show you what I mean. All right, so up first we have a simple circuit. You got your tail light. It needs to turn on, it needs power and ground. So the way in this example, we have power going through a fuse coming to the tail light. It's got power at all times, but it's not gonna turn on unless we give it ground. So that's how we're turning it on and off. We are sending it ground when we want it to come on. Now to do that, we have a switch here. So on one side of the switch, one post, we have ground coming in. So this is bolted to the chassis, it's ground, and this wire comes into the switch. Now, when the switch isn't pressed, when the brake pedal isn't pressed, that ground goes nowhere, it just stops right here. But when we press the brake pedal down, we now make connection between this post and this post, thus sending ground out into our brake light, which since it already has power, boom, our brake light comes on. When we let go of the switch, we break that connection. This wire no longer has ground, brake light no longer comes on. So that's a simple fused circuit. Obviously this is in simple terms. Normally you would have this power going to a fused box and then the power going through different fuses out to different things. But for simplicity, wire, fuse, taillight. Now, next, we have a high current item. This is a fuel pump for this example. So this is the way a lot of people try to wire this, and this is not the correct way to wire something like a fuel pump or a fan. So we got power coming out from the battery. Let's say you put a fuse in here. Now, the wire comes into the switch. When the switch is off, the power stops there. But when you turn the switch on, it then sends the power through the switch to the other posts, and then that power goes to our fuel pump, which already has ground. This is gonna have ground at all times. We send it power, we turn it on. Now the problem with this is that fuel pump, let's say this is a big aftermarket fuel pump, it's gonna draw a lot of current, and now you're taking all of that current that it's drawing is going through this switch, which the switch is not designed to handle that much current going through it. So to mitigate that, you use a relay. So this seems complicated, it's really pretty simple. So we've got power and ground to the relay, and then we've got power coming from the battery direct with a fuse. Now this is going to be a big heavy 10, 12 gauge wire. And then we've got power going out to the fuel pump. Same situation where the fuel pump is grounded at all times. To turn it on, we're going to give it power. So to turn it on, we still have our switch, but instead of the switch carrying the current, the switch is just there to turn the relay on, to cycle the relay. So the relay has ground at all times. We then give it power with our switch. So the power comes out of the battery to one side of the switch. When we flick the switch on, it then sends power out to the relay. But instead of that power carrying through and going to our fuel pump, that power just cycles the relay, which cycling the relay then makes connection from this heavy gauge wire here to this heavy gauge wire here. So now our power is going through this wire, through the relay, and then out to our fuel pump. All the switch is doing is carrying enough current to switch the relay over, to cycle the relay. So then the relay is taking the load of the current that this is drawing. Now this is the way you'd wire fans or fuel pumps or anything like that that's going to draw heavy current. And we could switch this as well. So this could be on the ground, and then we could have constant power. So this relay could have power here all the time, and then when we flick the switch, we give it ground. Same concept. And instead of a physical switch, this could be an output from the ECU. The ECU has a wire coming out. You could use that wire to cycle the relay so it's not carrying any current. You don't, like a wire coming out of a ECU for a fan or something is not at all designed to carry the current of that fan, whether it's on the ground or the power side. It's just there to switch. It just has enough load carrying capability to switch a relay, which then carries the current. So that brings us to the PDM. So this seems a little more complicated, but we've got all scenarios on here. So we got a tail light and a fuel pump. So, tail light situation, same concept with the switch. We've got ground going to one side, ground coming out. When you press the switch, that ground carries through from this post to this post and goes down here and into our PDM. Now, our PDM has a heavy gauge power wire, and this is our power feed that's going to go out to all of our stuff. The PDM is also grounded, so it itself can turn on. So, our power is going to come in here, and then there's a circuit board that's going to distribute that power. It's a power distribution module. When this wire gets grounded, i.e. when we press the brake pedal, it's going to ground this pin. Now this is where the programming comes in. We're going to go in there and tell the PDM, hey, when pin 19 gets grounded, I want you to send power out of pin 23 to our brake lights. So when you press the switch, ground comes in here, it tells it, hey, that's what I want you to do, and then it sends power out to our taillight. Now our taillight's gonna have ground all the time, and we're gonna be sending it power. Same concept with the fuel pump. Now for the fuel pump, we don't wanna do this on a switch if we don't have to, so we have the ECU do it. So we set a parameter in the ECU, and when we want it to, it will then send ground to this pin, and we'll say, hey PDM, when pin 10 gets grounded, I want you to send power out of pin 20 to power our fuel pump, which already has ground. So when the ECU is ready, it'll send ground out, boom. PDM will say, okay, cool, we're grounded here. Now let's send power out to our fuel pump. But we can also use our keypad. So in our keypad example, instead of having to have the wire, the power, run to the switch or the ground, and then from the switch to the relay, for each individual switch, we have 8 buttons here and only 4 wires going to our PDM. So we have power, we have ground, that powers up the keypad, and then all of the signals from these buttons come through CAN bus. So it's a twisted pair of wires. Imagine it like a USB cable. And those send, computer lingo to the PDM and can turn on all those things. So we have 8 buttons, and all we've got to do to wire those is 4 wires running to our PDM. So that's the gist on what we're programming here, is what, say, each button does, what each of our inputs and outputs do, when we want certain things to turn on, what certain things are. Now the cool thing with the PDM is you can get kind of slick and do all sorts of stuff. So we can have it to where the ECU turns on our fuel pump, but let's say I don't want the ECU to turn on a fuel pump. I can also say, well, if I press this button, then it doesn't matter if the ECU is trying to turn the fuel pump on, don't turn it on. Or I can say, hey, if I press this button, turn the fuel pump on. Or if the ECU tells it, turn the fuel pump on. Or I could say both. If I have to have the button pressed and the ECU has to send signal to then turn the fuel pump on. You can do all sorts of crazy trick stuff. So that's what we're working on now. We have wires, we have our power wires going out to all of our different things. So power is coming in to the PDM and then going out to, say, our fuel pump or our fans. And then we have our inputs, which are coming from the ECU. So we've got that connector there, and those wires come in here, and they're what's going to tell it to turn things on. So for example, our fuel pumps. So we have our lift pump and our feed pump. So the lift pump fills up the basket that our 3 fuel pumps are in. So that pump is just filling a little reservoir. Then our feed pump is going to send that fuel to the engine. So we are going to have it set up where our lift pump and our feed pump come on at the same time. They both have to be working to get fuel to the engine. Now, we don't need our second pump or our third pump if we're just idling there, if we're just driving around. So we're going to set it up to where those 2 pumps come on, and then for the second pump, we're only going to have that pump come on above, say, 3,000 RPM. We can do whatever parameters we want. We could do boost-based, load-based, RPM, TPS, both, all 3, there's several ways we can do that, but we'll set it in the ECU to where the second fuel pump will only come on when we need it. So that way we're not running 3 fuel pumps when we don't need to. Now, the third fuel pump we should not need to make the power we want. We should only need the 2 feed pumps. So what we're gonna do is we're gonna set up a parameter. We're gonna be monitoring our fuel pressure. So we're gonna set up a parameter to say, hey, if our fuel pressure drops below 45 PSI, 50 PSI, whatever our target is, then I want you to turn this third fuel pump on. So that way, if one of our fuel pumps goes out and causes our fuel pressure to drop off, the third fuel pump will kick on and take up the slack. So if that were to happen, then a ground signal would go out through one of these wires into that given pin, which would then be programmed in here to say, okay, when that pin's grounded, send power out to fuel pump number 3. So I know that was a lot of technical mumbo jumbo, but hopefully that demystifies it some. It's really all pretty simple. I mean, even wiring an engine is effectively the same thing. You know, an injector works by having constant power, and then you send ground to it. When it gets grounded, injector opens, it sprays fuel. That's that. So it's all pretty simple. The only addition on an engine is mainly sensors. You know, you have your crank and cam trigger, you have pressure sensors, you have temperature sensors. They all work a little differently. Still pretty simple, but wiring's really not that complicated. It's really not. It's important to do it right. Like if you wire fans off an ECU with no relay, you're going to burn up your ECU. If you wire them through a switch, it may work. It's not going to work long term. If you wire them just off some ignition wire for your radio, not going to work long term because all that current is going through there. So anyway, I know that was a whole lot of jibber jabber. I'm going to get back to programming. So my goal is to get all my programming done. So how I have my inputs and outputs here, all of that stuff is set up and programmed. And then we can give power to our ECU. We got to run power and ground directly to it. We have our power set up here. Then we can use the PDM to turn on the ECU and the ECU to go turn on other things. And start getting that programmed as well, or at least powered up. We need to get the wiring for the dash in here so we can get that powered up as well. So we got to do some wiring, some powering up. So I'm going to get back to programming, and then we'll get to doing a little more wiring, see how many things we can get fired up. Because once all that's done, we're fluids away from trying to start this thing. So this is an important step of the process. I'd like to get it finished up so we are ready when we're ready. So enough jibber jabber. Back to work. All right, you can see I've got everything in here. Fan 1, fan 2, fan 2.2, fan 1.2, because those are sharing 2 20 amp channels, so 40 amps total. So I've got everything set up. If we go in here, start all channels, live data, so you can see the status of everything. Now what I'm doing is taking this, which is alligator clip to ground, and putting it in the different pins that are going to come out of the ECU. So the ECU will send ground through these to turn all these things on. So if you watch the screen here, you can see there we've got fuel 1 on, or no, fuel 2. So that's fuel 2. And that's fuel 3 down there at the bottom. 3 is water pump, which I don't think I have that set up. But yeah, got most of them set up. Check to make sure they're all working. So the one thing I need to do now is figure out the button pad programming. I haven't figured that one out yet. So get back to it. All right, we got the switch button pad set up and working. So check this out. Let's see if I can hold that there. Ready? I'm gonna press the starter button. We got 12.5 volts down here. Boom. All right, let's test some more stuff out. We'll go ahead and put a 2-pin connector on a headlight, which we need to do anyway. Got these little headlights that we're gonna use. I'm gonna make a little bracket and put them right here, and then we're gonna attach lenses to the fenders. So basically it'll just be the little headlight tight in here, hopefully out of harm's way, and then the lens cover probably tint so you don't see it sitting in there. And it'll look like a normal headlight, because the actual factory headlights are huge and they're super heavy and they have to sit here. But these are all kind of broken and janky on this thing. We plan on cutting those off, cutting all of this off, and just having the inner fender and basically where the fender arch mounts. So that's why we decided to do this. So yeah, let's put a connector on it. Let's try it, see if it all works. Normally, this is kind of out of my order of operations. Like normally, I would have the car all done before I started messing with programming this stuff or anything like that. But it's kind of nice to get this part out of the way and, you know, verify everything works before we finish it out in case we have any issues. So let's throw a connector on this thing. Let's quit jibber jabbering. All right, so in theory that should come on with headlights because they're plugged into headlights. Oh. All right, I figured it out. This is my ground pigtail, which I still need to make the other side and ground, so I didn't have that done. So there's the headlight working. Boom. Let's try the other side. Did this really stop working? That's the worst feeling with wiring. You're like, everything's good, I tested it with a voltmeter, and you go to check it, and then it doesn't work. So same situation here. Our ground plug back here. Boom. Alright, cool. Most of the rest of this stuff has a prerequisite. We can test those if we want to. We probably will, but right now I need to finish those grounds out and stuff. But sweet, things seem to be working. So cool. Boom, turn that off. Kill power. We have officially an alive vehicle in the sense that it has power. Things can turn on. So with that being done, now it's time to have an alive ECU. All right, good news. I got my locks in for my connectors for my rear harness. Perfect timing. So that's actually done now. Got all those locks in. Pretty pumped on that. Josue is finally back. Now that I'm not contagious anymore. Finally have some help again. So he's gonna work on our pass-throughs for our Egt sensors. So instead of trying to run these through the firewall, if we did that, basically to have a grommet big enough to pass them through, it wouldn't seal tight here. So we'd have a bare, like an opening in the firewall, which you don't want. That's why it's a firewall. So I got, where are those things? Oh, here they are. I got these that Kevin from KSR recommended. So these are gonna bolt into the firewall and then the connectors slide into them. And then you just plug these into there. So we'll have, basically if we need to pull the header or something, we just pull, and we can pull the header off. So a much cleaner way to do it. Pretty pumped on that. I'm glad he sent me a message about these. So anyway, so he's gonna work on getting those in, and I'm gonna start working on my ECU power wire, get that routed out. So big important thing on the Hollies is that you run the main power and ground to the ECU direct to the battery. It tells you this a million times, and I want to cheat, and I want to run it to these bulkheads because it would be easier. I wouldn't have to pass it through. I wouldn't have to seal up, you know, grommet it or anything, but I know better. We're gonna run it direct to the battery. So we need to get it drawn out, figure out how long it needs to be, and we can cut it. I want to sleeve it with the heat shrink loom just to make it match everything else, and so on and so forth. So I'm gonna quit jibber jabbering. We're gonna get back to it. So once I got this thing routed out, I figured out how long it needed to be so I could cut the excess off and then we could re-loom it. So I hate the mesh style split loom. It's just big and we heat shrunk loom everything else. We needed this one to match. So I took the extra time. It's painful sometimes, especially when you're doing something like wiring that's so tedious for the amount of progress you get done. It's really rewarding, but it's like you do a lot of work for what feels like not much progress, and this is one of those things. It took me and Josue a minute to get this thing slid over there, but we got it on and made up some time by using a little torch to heat shrink it instead of using a heat gun, because you got to wait for the heat gun to heat up. The torch is significantly faster. You just got to be a little careful. But with that, we got the ends crimped on it to go to the battery, got it roughly routed, got it hooked up to the battery, and now we officially have our main power carrying to our ECU. All right, we got our power wire in, routed, hooked directly to the battery. Definitely glad we took the time, even though it was a fight to get that sleeve on. Downloaded the new software, because I have the Terminator X software. I've never used the V6 Holley General EFI software. This is a new realm for me. So we're about to hook up to the ECU. Hopefully got bulkhead number 1 in for our Egt sensors. Pretty exciting. Snazzy looking unit. We did realize that these are different lengths, which, I mean, makes sense. You would, like, it's great that they are. I just didn't realize that they were. But that makes it a little easier, and we were able to tuck it over in this corner. So I don't know where he's gonna put the other one, but yeah, that's pretty much where I thought about putting it. So yeah, get that in. Look at that, we're cruising right along. So I'm gonna try to get hooked up to the ECU. Let's see what happens here. What do you think, Josue? So main power there, okay. Ignition. Now the ECU should be on. Must update the ECU firmware. So while the firmware was updating on the ECU, I wanted to go ahead and get the wiring routed out for the digital dash. So we loomed up the power wires to it. It needs a power source and got that all routed across the car. All right, we got the dash wires done. So heat shrunk loom this too. The power side of it comes over here, plugs into CAN bus, and then I made a little connector for power and ground. So it gets power off the PDM, same as the ECU. The ECU actually doesn't really take any of that power, it's just used to turn it on. The dash though will take that power. So that's why we did it that way. Let's see if it turns on. Ha-ha! Look at that. Boom. Digital dash is alive. Sweet. All right, so we gotta mess with that and get it set up. We need to see if we need to upgrade any firmware or anything like that. All right, Josue got the other pass-through done. We just gotta clean up the wiring there, get it zip tied kind of nice and out of the way, but really pumped that those are in. That's done. That's something that's been an oddball thing on the checklist for a while. We got all of our stuff, firmware updated, dash firmware, all of that is done. All that's left is to get a base tune, load it into the ECU, work on, you know, setting up our dash how we want it, you know, what information we want to have on there. Probably use this one, that's what I have in the truck. So we need to get that done, but pretty well close to being ready to start this thing. All that we really have left to physically just at least try to start it is crimping these oil lines, get that done, get the oil system primed, put our injector harness in, and load a base tune. That's it. So we are really close to the first fire up of this thing, but we still got some other odds and ends that we need to get finished up first before we worry about that. There's no point in starting it if we're not ready to run it. We'll probably get impatient and start it ahead of time, but for now, we're gonna keep trucking along. But as of right now, we're out of time. So I'm gonna go ahead and end it here. I'm gonna quit jibber jabbering, enough jibber jabber. I hope to see you guys next time, but for now, that's it. Thanks for watching. Thanks for subscribing. Goodbye.